Good evening, everyone. So, we'll be starting our class now. Today's topic is measure of relationship, measure of relationship. We've talked about measure of variation. We've talked about that. So, we are going to measure of relationship. I want to talk about measure of relationship. It's certainly talking about correlation and regression. I'm sure you'll have heard it one way or the other. And if you've not heard it before, it's fine. So don't mind this. So firstly, we are going to start with the slide so that we will move from there. So basically, measure of relationship, how to measure the relationship, how to know how X is relating to Y is done through correlation and regression. So you want to know what it is. That is what we'll be jumping into. That's what we'll be jumping in. So I'm sharing my screen and I'm sharing the slide. So let me share my screen. So yes, I'm sure you can all see my screen. So as you're all seeing here, measure of relationship, correlation and regression. So it's one of the important topic. If you've been going through class question, you will see that it's one of the most important topic in QA. You will see something like Spearman, you will see Spearman-Cranks theory, you will see piercing, you will see different things, piercing, Spearman. This is what it's talking about. So firstly, we want to know what is the meaning of correlation, what is the meaning of regression, then we'll progress to calculation. So we are starting with correlation. It says correlation measures the degree of association. When we talk about association, we talk about relationship. So it measures the degree of relationship between two variables. Measure degree of relationship between two variables. Therefore, two variables are said to be correlated or related when change in one variable results in a change in another variable. So it's talking about two variables that are related. It's talking about two variables that are related. So when there is a change in one, definitely it's going to affect the other. So it's talking about the changes that affect two variables. So it's talking about the relationship that affect two variables. So it proceeds and says the degree of correlation between two variables x and y is expressed by a real number which lies between -1 and +0. So everything, all the variables we're going to be talking about will be between -1 and +0, inclusive -1 less than r, less than equal to r, less than equal to -1. It's the same thing as saying between the range of -1 and 1. So when we go into this class, you are going to understand more. And this it is called correlation coefficient or coefficient of correlation. So it's talking about this number between -1 and 0. So I want us to note this very well. Simple correlation is basically classified according to the value of its coefficients. Here we have one, positive correlation. You want to talk about classification of simple correlation. It's classified into different bases. Note this because of your short answer question and your objective. Number one is positive correlation. So positive correlation is 0 less than r less than 1. So it's talking about it's between 0 and 1. So on a normal English term, it's talking about positive figures. That's what it's talking about. So another one is perfect positive correlation. So when we talk about perfect positive correlation, is R equal to 1, R equal to 1. So when they say something is perfect and it is positive, you see that the first one I talked about, which is positive correlation, is between 0 and 1. So this second one, perfect, is just 1. Just 1. Hope you are taking note of all this. So the third one is negative correlation. So when you talk about negative correlation, it's between -1 and 0. -1 less than R less than 0. So it's between -1, the range of -1 and 0. And when you now come to say perfect negative correlation, we say R equal to -1. It's like putting it in form of how the positive correlation is and perfect positive correlation is. It's also the same thing as it relates to negative correlation and perfect negative correlation. So for the last one, the zero correlation. Zero correlation, it means that R equal to 0. So that's what it's saying. So that is the simple term of correlation and classification. So now let's go to the main, like the main thing you want to go to. This is the calculations I want to drive into. So measures of correlation. How are we going to calculate this correlation? It says the measures of correlations can be determined by having the following method. Note, we have two methods of correlation. We have two methods of correlation. The first one is Pearson coefficient of correlation. The second one is Spearman rank correlation. So let's calm down first. Take a deep breath. I repeat, the first one is Pearson, Pearson. So it actually has two names. It can be used interchangeably. The first one is, it can be called, this Pearson I said, it can be called product moment correlation. Product moment correlation coefficients method. And it can also be called Pearson coefficient method. So now in a question, you might just say calculate correlation using product moment. And in your mind, it's only Pearson, Pearson, you know. You'll be like, what is product moment? That's why you have to know the two names. If you are given two names, you have to know it. So in case they use Pearson for you, you say, okay, I am here. I know what I say. And in case they use product moment for you, okay, we did here, the same way we. So you already know how to. This is the same thing, just use the word interchangeably. So I proceed. So the degree of correlation between variable x and y is measured by the product moment correlation coefficient R. So note, whenever you see R, it means correlation coefficient. So this is the formula for our Pearson coefficient correlation. This is the formula. So as I was saying, this is the formula. So it says R equal to N. I'm not even supposed to be explaining what N is by this time of the day because it is something we're all familiar with. When you say N, N means number of terms. Something we know, numbers. So, but let's proceed. N summation. Whenever you see something that looks like E, it is summation. It is like something E that is big. It's summation. So N summation XY. If you know when they put XY together, it means that it's multiplication. They multiply X times Y minus in bracket summation X times summation Y over square root of, in bracket, you have two sections under this. The first one is N summation X squared minus bracket summation X all over squared. See, there is a difference between these two. And I'm going to explain it when solving the question. There's a difference between N summation X squared and in bracket summation X all over squared. There's a difference. I'm going to explain. Let's just listen. So that is the first jacket under the square root. The second jacket under the square root is N summation Y squared minus bracket summation Y all over squared. Then all together, we have a jacket, we have a bracket, anyone you call it, then it is squared. So when we solve the question, you understand meaning of this formula better. So when we talk about N, That is what we know, which is number of pairs of observation. So now, in other words, we can say R equal to covariance xy. This one numerator can also be called covariance over square root of variance of x, variance of y. So now let's dash into the sample now. I'm sure anyone that missed this class are going to listen to the recording because we cannot postpone this class. There is a lot of things we need to we need to do. Yeah,